Stars form in cold, dark clouds of gas and dust in interstellar space. A blast wave from an exploding star, or some other disturbance rippling through the gas, causes clumps or cores to form. Each core gradually contracts as gravity pulls it together. At the same time, the core rotates. Near the centre, the collapse accelerates. The energy of the falling gas heats up the centre of the core. A protostar forms, surrounded by a zone clear of gas. But a large cloud of cold dust and gas still shrouds the new star. The temperature at the centre gets hot enough for nuclear reactions to start. The star spins faster as it shrinks down, and the surrounding ball of gas flattens into a disk. Gas streams out from the poles. The wind of gas from the star clears away its surrounding cocoon. Finally, the new star settles down to a period without much change. Turning hydrogen gas into helium provides it with a huge supply of nuclear energy. Bigger stars form and change much more quickly than small ones. In fact, everything about a star, its size, its colour, what happens to it over its life, is fixed by its mass. The most massive stars are bluish-white. We can follow through the stages in the life of a star similar to the Sun. About 5 billion years ago, the Sun formed from an interstellar cloud. Then it settled into a long period as a stable yellow star. In another 5 billion years, the Sun will start to run out of hydrogen as a nuclear fuel in its central core. Then a series of dramatic changes takes place, marking the beginning of the end. For a further billion years, the brightness of a solar-type star does not change much, but its outer layers expand until it has doubled in size. Its colour darkens to orange. In the following billion years, the Sun grows to truly giant proportions, 100 times larger than now, and becomes 1,000 times brighter. It also starts to blow off significant amounts of material. After a temporary drop in size, there is a final fling in which the Sun gets larger, brighter, and redder than ever. Inside, its structure is unstable, and it pulsates slowly in and out over several months or so. The Sun's surface eventually extends as far as the orbit of the Earth. Its outer layers keep blowing off into space until the Sun has lost almost half its original mass. The last layer, round the innermost core, is flung off as a glowing shell to create a planetary nebula. It exposes the core of the Sun, which has shrunk to be about the same size as the Earth. This core is now a white dwarf star. The white dwarf just cools down and fades over a very long period. Stars up to 8 times the mass of the Sun follow a life track similar to the Sun's. Larger stars are different. We can follow what happens to a 12 solar mass star as an example. Starting off blue-white, it expands, cools, and starts to turn yellow. For a while it becomes unstable, pulsing in and out over a period of about a month. Eventually, the massive star becomes a red supergiant, 1,000 times larger than the Sun, shedding some of its material along the way. In the star's core, a series of different nuclear processes keep it shining until a core of iron 1,000 kilometers across is created. At a critical moment, the core collapses in under 1/10 of a second until it is less than 50 kilometers across. Part of the imploding core rebounds in a shock wave that blows the star apart and produces a spectacular supernova explosion.